Hey everybody, it's Michael Antonio, and welcome to Runtime Type Info in the CDK. Okay, so today I'll be using CDK Orchestration 0.1.21, and the code and slides for this lesson are checked into CDK Orchestration Examples in GitHub, and I will be putting links in the description. Okay, so how do you know what a construct is? We have these functions, Stack.isStack, which tests for a stack, CFN element is CFN element, which tests for L1 constructs, and Resource is Resource, which tests for L2 constructs. But how do these functions work? And how can I create my own runtime type info? Okay, so what the CDK does is they use symbol keyed properties. That is, if you have an object and it is properties, usually the names of those objects are strings, like resource type or bucket name. But you can also have properties where the key is a symbol. And so what the CDK does is they create a global symbol in the global symbol table using symbol.for. And here they're using their package name as a differentiator here, so it'll be truly global, and then slash core.stack because the stack object is in the core library of the CDK. And so that becomes the symbol for the isStack property. And they set that property to true in the stack constructor. And they do that pretty early on so that if any of the code that they call wants to call stack.isStack, that'll come back as true. And they have the stack.isStack method. I have that copied in here. And it basically just says, do I have an object? And does that object have the stack symbol? And if it does, then it's a stack because that's a symbol that belongs to the CDK. So, okay, that's a way to do it. But why don't they use instance of or is prototype of? Well, is prototype of is really more of a JavaScript thing, and so it doesn't really map very well onto TypeScript. And as the CDK says, they use duck typing instead of instance of to allow stack elements from different versions of this library to be included in the same stack. So basically, if you had one library using one version of the CDK and another library using another version of the CDK, even if those versions are compatible, they're not going to say that the objects of each library are instances of the other because they're really not. Okay. So, and then the other thing that you can do, and we went over this in the last video, finding constructs, is you can do ad hoc RTTI. So here I have a test for is bucket, and what I'm doing is I'm using more of a real test here, which is the is CFN resource test. And this is my version, which just checks both is CFN resource from the CDK and is CFN element from the CDK. I just prefer that because it uses an actual symbol key property in CFN element. And then I check a property, and the property that I'm checking here is CFN resource type, and I'm just making sure that it's the bucket resource type. And for me, that's enough to say that something is a CFN bucket. You can take a look at the previous video for some more examples of that. Um, I have a class in CDK orchestration called construct runtime type info that will basically do this for you. You just give it the name of the symbol that you want, and here I call it service property name because I call these symbol keyed properties services. And here I'm putting my package name first, which is @machanto/cdk-orchestration, and then the class name .cfn transform, and that's unique. So that's why I do that. And construct runtime type info has two methods on it. Add RTTI and you pass it the scope. And if you call that, it will mark your construct with RTTI. So I usually call that from the constructor, similar to how the CDK does. and then has RTTI, which tests a construct for runtime type info, and I call that from the static is function. Okay, so I also have this service inspector aspect, and what this does is this writes the names from the global symbol table of symbol keyed properties of constructs to the tree.json file. And we'll take a look at this as well. And oh, it's demo time. Okay, so let's come over here, and over here you can see that I have fully expanded. Yeah, fully expanded, but not the join. Um, the AWS toolkit view of my CDK package, and over here I have the stack that we're using and the code that we're using for today, and I have my tree.json file. But first, let's take a look at main.ts. You can see that I create a new app, and then I have a service inspector aspect, and then I create my stack. So I add a service inspector aspect to the app, and that's going to write all of the symbol keyed properties to tree.json. And then I'm going to create our stack for today, which is runtime type info. I'm creating that as a child of the app. So if we go to tree.json, I'm going to go to the top here. Let's go ahead and just take a look at the stack object. So you can see this is runtime type info. That's the name of our stack. That's also its ID and also its path. And the construct info here tells me that it is a stack, and the fully qualified name of it is stack. Now, this is not what the CDK uses for runtime type info. Instead, they use this property. So this is the name of the symbol that is used by the CDK as the property that tells them whether or not an object is a stack. And this is a Boolean. And so when you look at these attributes here, so if you're using my service property aspect, or sorry, service inspector aspect, it will write out all of the symbol keyed properties. There's a lot of them here, but the one we're concentrating on is the stack property, which is a Boolean, and that just tells us whether or not an object is a stack. Now we can also do our own, as I said, and I've created a type called typed construct. So that's the class that I've created. It's a construct class, and it also has a Boolean property on it, which is runtime type info. And so we'll be taking a look at the code for that. If I take a look at some of the other children here, here's a bucket, and the bucket, it has the resource property. And the resource property tells you whether a construct is an L2 construct. And that's what my bucket is, because I said new bucket, and that creates an L2 bucket. And so, of course, its resource child is going to be an L1 bucket. And you'll see that and I'm just going to close the props here. So you can see these are attributes that were added by the CDK. These attributes were also added by the CDK here. This is the CFN element Boolean, and this is what tells the CDK that this particular construct is a CFN element. So that's the Boolean value there. You'll also see that I called Stack.of on this CFN element, and the way that you can tell that is that it has this stack.myStack. I actually have code in there that goes through and calls stack.of for every construct in this stack. And so if you take a look at the tree.json file for this lesson, you'll see that there are a lot of instances of this stack my stack. And so what they've done is they've taken their symbol name for stack, and they've appended to it .myStack, and that's basically a cache for stack.of. So when you say stack.of on a construct, the CDK has to go look up in the stack until it finds, or in the construct tree until it finds a stack, something that returns true for is stack, and then it caches that on the construct using this MyStack symbol, and it does that so that in the future it doesn't have to go back and do that again. And so you can look through here and you'll see a lot of instances of some of these different types of constructs. So here's the class typed construct that I created, and this construct was created just to show off runtime type info. And so there are two static properties here. One of them is typed construct RTTI, and this is a construct runtime type info. And the service property name here is my package name dot test dot type construct. And this is going to be set as a Boolean on the type construct every time you create a typed construct. And you can see that down here in the constructor where I call add RTTI. And so further up here, you'll see in the is typed construct, you see that I'm also calling typed construct RTTI, and I'm calling has RTTI. Now I also have an of function, which is similar to Stack.of. So if I have a construct and it either is a typed construct, or its parent is a typed construct, or its grandparent is a typed construct, or anywhere up the tree is a typed construct, then this will actually return that typed construct for me. So this is very similar to the MyStack property that we saw, and I'm implementing it pretty much the same way. So here I have a construct service, and a construct service is actually the base class for construct runtime type info, whereas construct runtime type info is managing a Boolean symbol keyed property. Construct service will just manage symbol keyed properties of any type. And so the factory here, so basically if we can't find it, then it calls the factory, and the factory may or may not be able to create an object for us. And here it's searching up the stack for a typed construct. It's stopping at stack boundaries, so that is the stop condition for the searching up, and then it just returns the scope of that. And so what that is doing is basically just doing basically the same thing as what my stack did. It's just doing it as my typed construct. And so that's how I do that. So that's the implementation of. And then I have this other function here, which is typed constructs, which returns all the typed constructs under a given scope. And this is just doing a construct tree search, which is something that we went over last time in finding constructs. And it does a search down, and you can pass it a stop condition. Okay, so given that we now have this class typed construct, which is a construct and has all of these functions on it, how does all of this work? So we're going to go to our runtime type info stack, and we're going to log out begin. And then here, I'm just going to show you some built-in RTTI against the stack. So is the stack a stack? Yes, it is. Is the stack a construct? Yes, it is. Is the stack a CF an element? No. No, it is not. Okay, so that works. And now I'm going to start creating some typed constructs. So I'm going to create one under the stack, and you can see that here. I'm going to create one under the app, and you can see that down here. So that's a direct child of the app. And then I'm going to create a bucket, and I'm going to create a typed construct under that bucket. And then I'm going to create a typed construct under the CFN bucket, which is the default child of the bucket. So that's the L. I'm creating a typed construct under the L2 construct and one under the L1 construct. So L2, L1. Now I'm creating another typed construct, which is I'm calling a parent, and it's going to be a parent of a bucket, and that's so that I can call typed construct of on the bucket. And then I'm creating a stack, which is a child of the runtime type info stack. I don't normally make stacks as children of other stacks, but I'm doing it here just to kind of show you how the stop condition will work in these tests. Okay, so let's take a look at our custom RTTI, and we're looking at a true example. So we had this parent called a parent, which I created as a type construct, and that returns true. So we got that right. And then we're going to, oh, here we're going to do a false example by asking if the bucket is a type construct, and it isn't because it doesn't have the symbol in it. So there we go. Now I'm going to look for all of the typed constructs in the app, and you'll notice that I am not passing a stop condition. So this will return under app, and it will also return the one in the substack, and it will return all the ones that I created directly in the runtime type info stack. Okay, and then let's take a look at type constructs under this stack, and that will be oh, yeah, in this stack. So this is in the stack. So basically, I'm doing a search for just the ones that are in this stack. And since there are substacks, I'm passing in a stop condition, which is Stack.isStack. And that's why you only see the children of runtime type info. You don't see the children of the substack in there. And then here I'm looking for all the ones that are under the stack, which is basically the same thing, except I'm not passing a stop condition. And in that case, we also get the one that's in the substack. So we get one more type construct because there is one in the substack. If you just look at the ones in the substack, we get just that one. And here I'm going to do type construct.of hosted bucket. And so that will return me the type construct that is above hosted bucket in the tree. And that is runtime type info a parent. Because if you remember up here, we created a parent and then we created hosted bucket under parent. So that works. And then I called Stack.of on all of the typed constructs. So let's see now, if we go back to tree.json, I just want to show in here. So here's the my bucket. Okay, here's a parent. Its child is hosted bucket, and its child is the L1 resource. So I'm just going to go ahead and close that. And so here we can see hosted buckets attributes, and um, it has my typed construct. So, and it also has my stack because I called stack.of on hosted bucket. It got a pointer to its stack as a property, and that's runtime type info. And then the construct my typed construct. So this is the type construct that's above it in the tree, in the same way that my stack is the stack that's above it in the tree, and that's runtime type info slash a parent. So you can see that here in tree.json. So hopefully that gives you guys some idea of how runtime type info is used in the CDK and how you yourself can use runtime type info to enhance your CDK applications. So thanks a lot, everybody, and I'll see you in the next one. Bye bye.